Okay. So by nodal analysis, all right. So you can see you have the circuit here for nodal analysis. This is the first circuit in your book. Okay. Take note that we have now two sources here, two sources. Huh? Okay, E1 and E2. All right. We have three resistors. Okay. So as per the title, nodal analysis, node. Huh? From the word node, nodal analysis. So we will determine the voltage, okay, at node A or VA here. Okay, how will you get the voltage across VA? Kita. Okay, by applying the nodal analysis. All right. So this is the current rule or the current law to determine. Okay, what should be the voltage? All right. Okay, from take note here, in nodal analysis, be careful with this rule. These two rules are the most important. These two. Once you make a mistake in these two, alas, yeah, you will arrive on the wrong answer. So be careful with these two. So anyway, this is just okay. Just be careful. It's just easy. Anyway, this first one actually. This is easy. Okay, this rule is by current rule, right? In which we know that in a node, all the current entering should be equal to the current out. In, out, correct? So that's why here, if we say, for example here, at node A or VA, at node A here, okay, I1 here is entering, I2 is leaving, I3 is also leaving. Alright? It's like I1 here is equal to I2 plus I3. Correct? Entering, leaving the node. Alright? So that we can say also, if we equate this to 0, this term or this form, if we equate to 0, it will be I1 minus, it become minus, I2 minus I3 will be equal to 0. General equation for the current. Alright, now the next step is to determine what's the equivalent I1, what's the equivalent I2, what's the equivalent I3. Now, as you can see here, the second equation here shows you what's the I1 equivalent in terms of, actually this is Ohm's law, V over R. We know that this is Ohm's law, I is V over R, V over R, V over R. But the issue here, what is V? Be careful with the V equivalent. If it says I1, means it's just like equal to BR1 over R1. By the rule. I1 means by rule, okay? General rule, Ohm's law rule. It's just equal to V1 over R1, or BR1 over R1, I1. Correct? But the thing here, since this circuit is different, be careful, what is the real BR1? What is the real BR1? Okay? Now look, a very short generalized thing. Alright? Why this I1 become 10 minus BA over 4.7? Why? Because see, I1 is the current flowing here, okay? Now, it means that if that's the current, I1, rule BR1 over R1, BR1, what is BR1? The voltage across this one, So the issue here, what is the voltage across BR1? This one. It is, look la, I'll tell you. We are after VR1, sa? We have a source. Okay? If we imagine a loop here, a loop on this, okay? If we imagine a loop by Kirchhoff's, the voltage here is equal to the voltage here, voltage minus this one, voltage should be equal to this one. Is that correct? The voltage here minus this voltage should be equal to this voltage because it's series. Kirchhoff's voltage laws, KCL, KBL. If you apply the rule by KBL, the voltage or the voltage here will be voltage here plus voltage here. So lala. Or the voltage here will be voltage minus this voltage should be this voltage. Equal zero. Or equal to zero. That's why this became 10 minus this voltage will be this voltage. That's how. That's why it became 10 minus BA. That's BR1. BR1 is voltage here minus this one is equal to this BR1. So lala. Like it chops. That's why it became 10 minus BA over 10. Also, now, let's go to minus I2, which is this one. Why it become BA minus 15 over 6.8? Same thing. This is BR2 over R2. Where is BR2? Hada is BR2. This BR2 or the voltage across R2. Therefore, what's VR2 equivalent? It is, if we are after here, it means that this voltage or this voltage minus this voltage will be this one. The whole VA minus this is this voltage, which is VR2. I'll just continue, okay? And now look, how about I3? Means VR3 over R3. VR3 over R3. So, what is VR3? It's VA voltage. Yes, it's VA voltage. It's equal to VR3. So, it's parallel. That's why VR3 will be the voltage here over this one will be, see, VR3 or the I3. So, because this one, VA is equal to VR3. And that will be equal to 0. Now, you see, that's why this is the most critical point only. You need to master this point, these two. How it comes. Okay, now after this it will be easy because what you need to do is to apply the mathematical rule. Okay, mathematical thing that you know. So by expanding, okay, by distributing, see, you distribute 10 over 4.6, expanding the equations, minus BA over 4.7 minus BA 6.8 plus, because negative it will become plus. So lala. Because negative here, it will become plus here. Correct? So it become plus 15. 6.8. Minus BA 10 kilo. After that, expanding again. Look. So, regroup. I regroup. I put the numbers here. Constant numbers. Then regroup all the VA on the other side. That's why it become like that. Okay? Because I need only VA. I need only VA. So, after that, okay, what is this? What is these numbers? This is the least common denominator. In your mathematics, the LCD, we call it least common denominator. The common denominator. So least common denominator of this one, this is, for this two equation, or this two function, we have LCD as this one. How? Just multiply this one, both. Multiply these two, you get the LCD. This LCD came from this also, product of this. After that, what's the next thing? Next process. Huh? So the LCD divided by this one multiplied by 10. This will give this one. LCD divided by this one multiplied by 15. It will give you this number. Math rule. Alright? Same thing here. This LCD divided by this one multiplied by VA will give you this equation or this number. Same thing for all. Alright? So this is a total. Okay, this is the resulting equation for both of the. Okay. Now, what happens now? Again, more simplification. What you did? Add these two. This will give you this number. Add those number. Will give you this number. VA. Alright? So after that, what will happen? We need only VA. We're after VA. Cross multiplication. Cross multiplication, because we need only VA. So this will go here up, and that will go here down. This point is equal to VA. So by calculating these numbers, you will have a value of 9.43, which is the same in our table. What you get? 9 point, what did you get? 9 point something, huh? 9.5, right? 9.42 by theory, by calculation. So after you get BA, it is easy to get I3, which is IR3. BA is 9.42 over 10 kilo. That will give you the current, IR3. I3. Alright, now, I know that, okay, tell us.